What if the Earth suddenly stopped spinning? Imagine a moment when the very axis that has cradled life for billions of years halts, as if someone pressed a cosmic pause button. The ground beneath our feet, which we have long taken for granted, would no longer obey the rhythm that has synchronized the cycles of day and night, seasons, and the very pulse of our biological clocks. To most of us, this might sound like the plot of a science fiction movie, but it's an exercise in intellectual curiosity that allows us to explore physics, neuroscience, psychology, and even philosophy simultaneously. It invites us to consider the fragility of the systems we inhabit, both external and internal, and to marvel at the intricate balance that has allowed life to persist on this spinning sphere for so long. But beyond the obvious catastrophic scenarios, there lies a subtler, more profound question. How would our brains, our perceptions, and our sense of reality respond to the sudden absence of rotation, the sudden cessation of a force we barely notice but which silently shapes our entire existence? The first thing to understand is that the Earth's spin is not just a convenience for marking time. It is a colossal store of angular momentum, a property of rotating bodies that resist sudden changes in motion. The Earth spins at roughly 1,670 kilometers per hour at the equator, a speed that gradually decreases toward the poles. If it were to suddenly stop, every object not firmly anchored to the bedrock would experience an instantaneous force, throwing it eastward at speeds unimaginably higher than any hurricane or tsunami ever recorded. Buildings, trees, oceans, even the atmosphere itself would surge violently. Our familiar world, the one structured around gravity and inertia, would be temporarily unrecognizable. But while these dramatic outcomes capture headlines, the subtler consequences on our physiology, perception, and cognition are equally fascinating. Our bodies have evolved under the constant influence of this rotation, and our brains have internalized its rhythm. From the vestibular system in our inner ears that maintains balance, to the circadian rhythms governed by the interplay of light and neurochemical cycles, to the neural networks that process motion, our cognition is finally attuned to a spinning world. What happens when that world stops spinning? How would our neurons interpret the sudden absence of a familiar constant? At the core of our adaptation to the environment is the brain's extraordinary neuroplasticity. Neuroplasticity is the capacity of the brain to reorganize itself by forming new neural connections in response to experiences, learning, or even trauma. It is the mechanism that allows us to adapt to new circumstances, to recover from injuries, and to learn entirely new ways of interacting with the world. In a hypothetical scenario where the Earth stops spinning, the sensory bombardment on our nervous system would be extreme. Imagine the vestibular organs, which rely on fluid movement in the semicircular canals to detect rotation and acceleration, suddenly receiving input that contradicts every prior expectation. Signals that previously indicated subtle motion would now register as catastrophic acceleration. The initial stress response would be overwhelming. The sympathetic nervous system would flood the body with adrenaline and cortisol, triggering fight or flight reactions. Yet within this maelstrom, the brain's plasticity would begin its quiet work, recalibrating neural circuits to interpret new sensory input. What initially seems life-threatening could eventually become a new baseline for perception, though the process would be chaotic, disorienting, and perhaps traumatic for our psyche. Human perception relies not only on raw sensory data, but on predictive models the brain generates to anticipate the future. These models, which neuroscientists sometimes describe as Bayesian inference machines, constantly compare incoming signals against expectations shaped by prior experience. In a world that has stopped spinning, these predictions would fail spectacularly. Every movement, every change in orientation, every wave in the ocean would defy expectations, creating a cascade of prediction errors. The consequences would extend beyond balance and motor coordination. Cognitive processes such as decision-making, attention, and even the perception of time are influenced by the stability of our environment. Studies in psychology have shown that when humans are exposed to environments that violate their expectations, stress levels rise, focus diminishes, and perceptual distortions become more likely. In essence, the sudden halt of Earth's rotation would not only topple buildings but could temporarily fracture the cognitive frameworks that allow us to navigate the world with confidence. But let us consider the metaphorical implications. If the Earth's spin is a signal, a pulse of energy dictating the rhythm of life, then the brain is a system attuned to interpret and synchronize with that pulse. The human body, in turn, is an energy network, constantly transmitting, processing, and redistributing forces and information. Just as a power grid experiences overload when an unexpected surge occurs, our neural networks would face sudden, unprecedented demands. Cortical regions responsible for motion perception, spatial orientation, and balance would be forced into hyperactivity, while the autonomic nervous system struggles to maintain homeostasis. The analogy is not just poetic. It reflects the underlying principles of energy conservation and signal processing that govern both physical and biological systems. The brain, like any complex system, thrives on regularity, predictability, and coherent feedback loops. Disruption on the scale of planetary spin cessation would challenge those loops in ways that are simultaneously terrifying and fascinating. Interestingly, some of the most profound insights into human adaptation come from studying extreme environments. Astronauts in microgravity, for example, experience altered vestibular function, muscle atrophy, and cognitive shifts as their brains recalibrate to the absence of gravity-driven motion cues. Deep-sea divers, high-altitude climbers, and even individuals subjected to virtual reality simulations reveal the brain's capacity for rapid recalibration. In each case, what initially produces disorientation and stress ultimately leads to a new form of perceptual competence. Applied to a stationary Earth, we can imagine a parallel process, a period of acute chaos followed by gradual neurological adaptation, where the brain begins to reinterpret sensory signals, internalize new patterns of movement, and restore functional equilibrium. The question then becomes philosophical as well as scientific. How much of our reality is constructed by these neural predictions, and what happens when the physical world violates them? Are we aware of the Earth's spin in a direct sense, or only through the elaborate interplay of our nervous system and the forces it has internalized over millennia? Moreover, the cessation of Earth's rotation would also challenge the circadian rhythms that govern sleep, hormone release, and cognition. The daily cycle of light and dark, while influenced by the planet's orbit around the Sun, is modulated by the rotation that creates day and night. Our internal clocks, anchored in the suprachiasmatic nucleus of the hypothalamus, rely on these light cues to synchronize bodily functions. Without rotation, days and nights would no longer be regular, producing a form of temporal disorientation with profound physiological consequences. Sleep patterns could fragment, hormonal cycles could destabilize, and the subtle feedback between alertness, cognition, and mood could unravel. Yet, as with vestibular adaptation, the brain's neuroplasticity and the endocrine system's homeostatic mechanisms would eventually seek a new equilibrium. The process might take generations or perhaps even induce evolutionary pressures that favor individuals with enhanced temporal flexibility, resilience, and adaptive cognitive networks. At the level of perception, the sudden halt of rotation raises fascinating questions about the nature of reality itself. Motion, balance, and orientation are not merely physical states. They are interpreted by the brain as part of a coherent narrative that allows us to interact meaningfully with our environment. The paradox is that what we experience as stable is actually a finely tuned equilibrium between external forces and internal predictions. If that equilibrium collapses, our perception of space, motion, and causality would become fluid, almost dreamlike. This is where the neuroscientific intersects with the philosophical. The abrupt absence of rotation forces a confrontation with the limits of our embodied cognition. How much of our understanding of the world depends on predictable, reliable motion? Could consciousness itself feel destabilized when the very rotation that structured our physical environment disappears? These questions bridge physics, neurobiology, and metaphysics, reminding us that the human mind is both observer and participant in the cosmic dance. And yet within these catastrophic possibilities lies a subtle twist. What feels like vulnerability, what feels like the overwhelming threat of forces beyond our control, is simultaneously the protective mechanism of the brain. When confronted with sudden disorientation, stress, and sensory overload, The brain initiates a cascade of responses, heightened alertness, hormonal surges, adaptive recalibration that are precisely designed to preserve life. In other words, the very discomfort, confusion, and fear we would experience are expressions of the brain's intelligence, its preemptive strategy for survival. The weakness we perceive in moments of instability is, paradoxically, the brain's strength. It shields us, organizes the chaos, and ultimately guides us toward a new form of stability. This dynamic reflects a broader principle in neuroscience and psychology. Adaptation often emerges through tension, uncertainty, and temporary disruption. The systems that appear fragile are often the ones most capable of resilience when properly challenged. Biologically, the sudden cessation of spin would have profound consequences for everything from atmospheric currents to oceanic tides, but it also presents an opportunity to reflect on the delicate balance of life systems. The Coriolis effect, which arises from planetary rotation, influences weather patterns, ocean circulation, and even the distribution of nutrients and heat across the globe. Stopping the spin would disrupt these flows, creating new climates, new environmental pressures, and new evolutionary challenges. The human brain, as part of this system, would experience these changes not only indirectly, through sensory perception and physiological stress, but also directly, through altered environments that shape cognition and behavior. Our adaptability, our capacity for insight, and our intellectual curiosity are not abstract qualities. They are deeply rooted in the physical and energetic structures that surround us. In this sense, the thought experiment is both a cautionary tale and a celebration of human resilience, revealing the intimate interplay between external forces and internal processing, between planetary mechanics and neural mechanics, between the observable and the interpretive. From a quantum perspective, one might even draw a metaphorical connection. Just as particles exist in states defined by probabilities until observed, our perception of motion and stability depends on continuous interpretation by neural networks. The Earth's spin provides a constant, predictable framework within which these probabilities collapse into coherent experience. Remove the spin, and the collapse becomes unpredictable, highlighting the role of the observer, our brains, in shaping the experiential reality of motion and time. While this analogy is not meant to be taken literally in a physical sense, it illuminates the astonishing subtlety with which the brain constructs reality from chaotic inputs. It is a reminder that intelligence, consciousness, and perception are not passive mirrors of the external world but active participants in its ongoing definition. The philosophical implications extend even further. Stopping the Earth's spin forces a reconsideration of human hubris, of our implicit assumptions about permanence, and of the limits of control. We live in a world where the ground feels stable, where day follows night, where seasons are predictable. Yet all of these certainties are contingent on a set of physical principles that could, hypothetically, fail in extraordinary ways. In contemplating the sudden halt of rotation, we confront not only physical catastrophe, but existential vulnerability. And yet the same scenario underscores a profound truth: adaptability. Resilience and consciousness are not external impositions on life. They are emergent properties of systems finely tuned to respond to change. The brain, in this context, serves as both witness and mediator, translating chaos into manageable information, transforming threat into insight, and facilitating the ongoing negotiation between organism and environment. If we zoom back to a human scale, we see that this thought experiment mirrors daily challenges in perception, adaptation, and cognition. We rarely encounter literal planetary halts, but our brains constantly navigate sudden disruptions, stress, trauma, learning, sensory overload, and unexpected environments. Each instance requires recalibration, prediction, and the engagement of neuroplastic mechanisms. The Earth's spin is, in a way, a metaphor for the predictable parameters that anchor cognition, and its cessation symbolizes the unpredictable, chaotic forces that life continually presents. By imagining these extremes, we gain a deeper appreciation for the quiet, invisible intelligence of our nervous system and the subtle ways it preserves coherence amid disorder. Ultimately, the thought of Earth stopping its rotation invites us to reflect on the intertwined nature of physics, biology, psychology, and philosophy. It challenges us to consider not only the catastrophic consequences but the adaptive possibilities, the emergent resilience, and the cognitive elegance inherent in our neural architecture. The world we inhabit is defined by rotation, rhythm, and predictability. Yet our capacity to understand, anticipate, and adapt reflects a deeper pattern of intelligence that transcends immediate perception. Our brains, our bodies, and our consciousness are not merely passengers on a spinning planet. They are co-authors of experience, active participants in the ongoing choreography of forces, signals, and information that define reality. What seems catastrophic may, in fact, be an opportunity to glimpse the extraordinary subtlety of adaptation, the hidden resilience of perception, and the profound elegance of neural and systemic organization. As the Earth spins, or as we imagine it halted, we are reminded that knowledge is not merely the accumulation of facts, but the cultivation of insight. The universe operates through forces both visible and invisible, predictable and probabilistic, external and internal. And our understanding of it is inseparable from our capacity to perceive, adapt, and reflect. The hypothetical stopping of Earth's rotation is not merely a catastrophic scenario. It is an intellectual mirror reflecting the intricate interplay between planetary mechanics and neural mechanics, between the tangible and the perceptual, between chaos and adaptation. It teaches us that our brains, though fragile in immediate confrontation with extremes, are profoundly intelligent systems designed to navigate complexity, reorganize after disruption, and extract coherence from uncertainty. It invites us to marvel not only at the physical laws that sustain life on a spinning planet, but at the cognitive and physiological architectures that allow us to interpret, survive, and even find meaning within those laws. So, next time you feel the earth beneath your feet, consider the invisible forces shaping every moment, every perception, and every thought. Consider the quiet, unheralded work of your neurons, your vestibular system, your circadian clocks, and your predictive models. Consider that what you perceive as stability is a dialogue between you and the planet, a continuous negotiation between system and observer, signal and interpretation, energy and awareness. The Earth's rotation is a constant, yet our consciousness interprets and adapts to it in ways that are invisible, immediate, and extraordinary. And in imagining a world where that rotation ceases, we glimpse the delicate balance between catastrophe and adaptation, between fear and resilience, between vulnerability and the hidden intelligence that governs life itself. The earth spins, and so do our minds, caught in a continuous, intricate dance that is at once physical, cognitive, and philosophical. What would you notice first if the world stopped moving beneath you? How would your perception, your cognition, your very sense of being adapt to a new equilibrium? Think about it, reflect on it, and perhaps share your insights in the comments below. If you found this exploration enlightening, make sure to like this video, subscribe to MindSpark Science, and join our ongoing journey into the intersections of physics, neuroscience, psychology, and philosophy. Together, we'll continue to explore the hidden patterns, astonishing adaptations, and profound mysteries of the world and the mind that surrounds us.